Algebraic expressions. Skills needed for today. Translate words into an expression. We're going to need to simplify an expression by combining like terms, and then we're going to evaluate an expression for given input. Otherwise known as, more informally known as, plug and chug. So when we get to this part, I'll give you an algebraic expression and some given input, and you'll just plug it in and clean it up. Okay, so let's practice the first skill, translation. Let's translate the quotient of a number and 2 plus twice the difference of a number and 6. Okay, always be on the lookout for those key words. Quotient. The quotient, how do you say the quotient of a number and 2? So let's start there. Quotient is a key word for division. So x, but I could say x divided by 2, but I'm going to write it like this. X over 2. So the quotient of a number and 2 plus twice, I'm going to hold the word twice the difference of a number and 6. So I'm going to temporarily ignore the word twice here. How do you just say the difference of a number and 6? The difference of a number and 6 is this. Then we want twice that difference. So notice that I'm going to, note to self, I'm going to need parentheses. Because if I would have just said 2x minus 6 without parentheses, that would have translated to twice a number minus 6. It would have translated differently. Because I want twice the entire difference of a number and 6. Alright, so notice we're not solving or anything. It's not an equation. We're just translating. Let's try another translate. Okay, here's another one. 5 subtracted from a number increased by the product of the number and 4. So first, how do we say 5 subtracted from a number? So be on the lookout. Whenever we see subtracted from a number, we're not going to say 5 minus x. We're going to say x minus 5. So it kind of translates backwards like that. Subtracted from, notice 5 comes behind the x. Okay? So x minus 5. So 5 subtracted from a number increased by, so increased by, and notice the comma. So I want this whole thing increased by something else. The comma is often a trigger that you're going to need parens as well. So that whole thing increased by the product of the number and 4. Product means multiply. So the product of 4 and a number, you could say 4 dot x, or you could just say 4x. Okay? So we could just, or we could just call this x minus 5, increased by 4x. All right, hope that helps. And now we're going to look at simplifying an algebraic expression by combining like terms. That's our next skill set that we had listed at the beginning. So what if you had to simplify, over here I'm just going to write by combining like terms. And you, of course, obviously have to be able to identify like terms to do that. So 2x minus 3, parenthesis, y plus 4, end parenthesis, minus 4x, minus 8, parenthesis, y plus 1, end parenthesis. So you should be thinking, okay, I'm going to use the distributive property. So, step 1, if you're looking for a recipe, step 1 is remove parens, and the only parentheses, I abbreviate parens. The only way we're going to do that is to distribute, okay, and then record. So we'll have 2x minus 3y minus 12. Again, if you're wondering how that happened, negative 3 times 4 is negative 12. Okay? Minus 4x minus 8y minus 8. Careful on signs. Notice that negative 8 times positive 1 is negative 8. Okay? When we arrive here, I'm going to draw the eyeball. Your eyeball has to scan and look for like terms. Now again, like terms, this is a like term with this. How come? Because it has the same variable and corresponding exponent. So they're both x's and they're both raised to the first power. It's not like one of them is being raised to the second power or the third power. So those are like terms. So combine means add. So you're taking 2x. This negative, by the way, belongs to the 4. So you could say 2x minus 4x, or you could say 2x plus negative 4x. Means the same thing. Combining 2x minus 4x to get negative 2x. Okay, let's try that again. negative 3y is a like term with what? Negative 8y, right? So negative 3y minus 8y go together to become negative 11y. Okay, and then sometimes I draw pictures. Negative 12 looks like it's a like term with negative 8. And a lot of people ask me, is that a negative 8 or a minus 8? Either way, it's negative. That minus sign belongs to the 8, so it's going to be read as a loss or a negation. So you have negative 12, lose 8, or minus 8. You're going to be at negative 20. Okay, when you arrive here, you stop. How come? Because there are no more like terms. This has an x, this has a y, and this is just a constant, a number without a letter. All right, hope that helps. Let's try one more simplify by combining like terms. Okay, again, we see parentheses, we see bars. We need to clean this up before we can combine like terms. So now we know we have to use the distributive property to get rid of those parentheses. So we know that's going to be 3a minus 12 plus 5a minus 15. Careful here, the bars are what? Absolute value. So the absolute value of negative 4 is 4, but this minus sign here is still there. Okay? And then plus 3a. All right? Now once we boil everything down to addition and subtraction, we can just combine like terms. So this is a like term with this is a like term with this, right? They all have a's. So 3a plus 5a is 8a, plus another 3a is 11a. So you can do that combining of like terms mentally if you like. Okay? Then here, negative 12 is a like term with negative 15, is a like term with negative 4. Okay? So negative 12 minus 15, that's negative 27, minus 4 is negative 31. When you arrive here, what do? You stop. How come? Because it's not an equation. We're not solving anything. You don't see an equal sign. You know, so notice the command too. The command is simplify. It doesn't say to solve. So you just combine all your like terms and then you're done. All right, now the final skill set here will be to evaluate an expression for a given input. Okay, notice the command is to evaluate. We have an expression, and then it says evaluate this expression for given input. So over here, you have your given input. All right, what does that mean? Well, like I said, informally, plug and chug. So, but you just have to be careful. So we're going to plug negative 1 everywhere we see an x and do a rewrite. When you plug it in, put parentheses around it. So 2 times negative 1 minus 3. Even when I plug my y in, so I'm going to plug negative 3 right there for y. So that's negative 3. Then I'm going to square it. Okay, plus 2, parenthesis, negative 1 plus negative 3. Okay? Now what happens is after you plug everything in, you end up back at please excuse my dear Aunt Sally. Do an order of operations. So we'll go inside these parentheses first. So if you want to note that, you're back at PEMDAS, please excuse my dear Aunt Sally. So negative 1 plus negative 3, that's negative 4. And the 2, I'm going to record that. PEMDAS says we can take care of our exponents a while, so right after our parentheses. So I'm going to take care of this right here. Negative 3 squared is 9. I'm going to record that. That 3 is still there, the minus, and then here 2 times negative 1. Okay, then PEMDAS says, or order of operations says that you should multiply before you add or subtract. So these two go together, 2 times negative 1 to become negative 2. These two go together to become negative 27, meaning negative 3 times 9 is negative 27. And these two times each other makes negative 8. You could say plus negative 8 like that if you like. Now we can just move left to right over addition and subtraction. You want to go left to right. So negative 2 minus 27 is negative 29, and then plus negative 8. Again, you have to think about money. If you're in debt, if you lose 29, if you gamble 29, and then you somehow gamble away another 8, you're even further in the hole, right? So you'd be out of how much money? 37. So you'd be 37 bucks in the hole if you're thinking about money. All right, hope that helps with evaluating expressions. That's our last skill set for today.